We want to graph the function below without a calculator. So our function is g of x equals 1/2 times the square root of negative x minus 3. So first we want to identify the parent function. So if we strip away the 1/2, the negative 1 inside the square root, and the negative 3, what we're left with is our parent function, which is just the square root of x. Now when we write the parent function, it's important that you actually write y equals the square root of x, so you're writing a function rather than just simply writing the square root of x by itself, which would be an expression, not a function. So now we want to identify the transformations that have taken place. And in this case, there are 3. Again, if you think about stripping away the 1/2, the negative 1 inside the square root, and the negative 3, those are 3 different numbers that we could strip away. That means each one corresponds to a transformation. Now, I mentioned in class that I always recommend shifting last, so I like to actually list the shift here as my third transformation. Sometimes that's the easiest to identify. So the minus 3 here, because it is outside of the radical, it is not inside the square root, it's outside, this is going to be a vertical shift, and because it's negative, it's going to be a shift down 3. Now, the 1/2 that's here in front of the parent function, getting multiplied by the parent function, this is going to be impacting the y values. Each y value is going to become half as big, so that's going to be a vertical compression. Next, we have this negative 1 inside the parent function being multiplied by x. So that's going to be a reflection. And if you're struggling remembering what you're reflecting over, just think about a graph quickly and think about if you have positive x values over here, positive 1, 2, 3, let's say, and now we're wanting our x values to become negative. That puts us over here at negative 1, negative 2, negative 3, and so on. Look what's actually happening. If a point goes from, let's say, positive 3 over here and goes to negative 3, you just jumped across the y-axis. So when the x's become negative, we have a reflection over the y-axis. But the order of these first 2 transformations, the vertical compression and the reflection, are certainly interchangeable. So those don't have to be set in stone. If you prefer to reflect first and then deal with your compression, that's fine. It's just my preference to always do the compression first, and then I choose to reflect, and then always shift last in the end. So now let's work on graphing our parent function. Y equals the square root of x. So we know we cannot have a negative inside of a square root, so we'll start with 0. We know the square root of 0 is 0. The square root of 1 is 1. If I keep going over to 4, the square root of 4 is 2. And if you keep going to 9, the square root of 9 is 3. So these 4 points are certainly enough to graph our parent function, which looks like half of a sideways parabola. So now we'll start with the vertical compression. So the vertical compression took place because of the 1/2 that was out in front of the parent function getting multiplied by the square root of x. So that means that every y value is going to become half as big, or said another way, every y value is going to get multiplied by 1/2. So if we start at the origin, the y value is 0, but 0 times 1/2 is still 0, so that point doesn't change. Going to your next point, the y value is 1, so 1 times 1/2 is 1/2. So that means that the y value for the second point changes, and the y value becomes 1/2. Look at the third point on your parent function. The y value there is 2. 2 times 1/2 is 1. So the y value of that point changes and becomes positive 1. Lastly, for the point that I have graphed, the last point, the y value is 3. So 3 times 1/2, or half of 3, is going to be 1.5. So that y value changes to 1.5. So what I have in red here is the vertical compression. If you wanted to write the equation for my red graph, it would be y equals 1/2 times the square root of x, because we haven't shifted or reflected, but we have done the vertical compression. Next, we reflect over the y-axis. So again, 0, 0 does not change, but my point, I'm looking at my red graph now, my point is at positive 1 and up 1/2, so therefore I'm going to -1 up 1/2. That point just jumps across the y-axis. So my, third point was right 4 and it's up 1, so that's going to be at -4, left 4, up 1 when we jump across the y-axis. And then my last point was over here at 9 and up 1/2, so it's going to jump over to -9 up 1/2. So in blue, I have done the compression, the vertical compression, as well as the reflection. So the equation for what I have right now graphed in blue would be y equals 1/2 times the square root of -x. We've done our compression, vertical compression, as well as the reflection. Finally, now we take care of the shift. In this case, there's a shift down 3. So we literally are going to take all 4 of our points and just shift them down 3. So the origin gets shifted down 3. The point that was at the origin, I should say. So down 3 moves us to 0, -3. Our next point was at -1 and up 1/2, so we're just going to count down 3, and that's going to put you about right there. That looks like -1 down -2.5. It's certainly easier when we're doing the shifting to do the points, maybe the lattice points. When I say lattice points, I'm talking about the points that have integer coordinates, so positive 1, 2, 3, 4, or -1, -2, -3, -4. Something that's easy for you to shift, something that's not including a fraction or a decimal. You could certainly do those first because you already know the general shape of the graph. So doing the lattice points might just be enough. So the third point is at -4 up 1, so we shift down to 3 if I count, down 3. I was counting there, down 3, so that would be at -4, -2. And then lastly, we had this point at -9 up 1.5, so we're going to shift it as well, down 3, and it looks like that's going to land us at -9, -1.5. So literally just taking each point and counting down 3 units. And then you can always star your final answer or mark it. The original function up here I had called g of x, so you could just say this is g of x, this is your final function that has had all 3 transformations. And as you get better at these, you'll find you probably won't have to do all the intermediate steps. You won't have to graph every single transformation. You'll start maybe combining 2 or even 3 at a time, and that's great. In the beginning, though, if you need more practice, then certainly color code and do each transformation separately. Last thing would just be a check. Remember, if you're sitting there on a test wondering, okay, did I do this correctly? A check's not a bad idea. So pick a point that is on your graph. And I'm going to pick a lattice point. I'm going to pick this one right here, which appears to be -4. Try that again. -4, -2. So let's just check. So the original function, g of x, was 1/2 times the square root of -x minus 3. So in checking, we're just going to plug in -4 for x and -2 for y. So we're just substituting here. So we're saying that the y value is -2, and then we're substituting the x value that we got for our graph, which was -4. And we're just testing to see if this is true. You could even put a question mark over the equal sign. So let's just simplify a bit here. So we end up with the square root of 4. We know the square root of 4 is indeed just 2, and 1/2 times 2 is 1. So we end up with 1 minus 3, which is -2, and you'll notice that's exactly what we got for our y value, so yes, this checks out. It appears that we graphed this correctly. And there's our graph for g of x.